The rendering limits of the cosmos. If you are playing a massive open-world video game, the computer running it faces a fundamental hardware challenge. It cannot render the entire digital universe at once. Doing so would instantly crash the system. So developers use a trick called frustum culling or dynamic optimization. The game only loads and renders the graphics you are actively looking at. The world behind your character's back technically doesn't exist until you turn around. Now look at the subatomic rules of our reality. In quantum mechanics, there is a famous phenomenon known as the double-slit experiment. When physicists observe a subatomic particle, it behaves like a physical solid object, a localized bullet. But when they stop looking at it, the particle instantly dissolves into a wave of probabilities. It spreads out, existing everywhere and nowhere at once. For a century, this has driven scientists mad. But to a software engineer, this isn't a mystical paradox, it is a standard code design. The universe only calculates and renders the precise hardware locations of matter when an observer is looking at it. When no one is watching, the cosmos saves processing power by keeping reality in a low-resource mathematical cloud. We aren't discovering the laws of magic. We are stumbling upon the optimization protocols of a cosmic operating system. The processor speed limit. Every computer system in existence has a maximum processor speed, a limit to how fast it can calculate bits of data. If our universe is a simulation running on a giant quantum computer, it too must have a hardware ceiling. And it does. We call it the speed of light. In physics, the speed of light, approximately 300,000 kilometers per second, is the absolute speed limit of the cosmos. Nothing with mass can exceed it, and even information cannot travel faster. But why should a cosmic speed limit exist at all? Why shouldn't a particle be able to accelerate indefinitely in an infinite void? Because the mainframe running our reality can only process a finite number of calculations per second. Just like a video game has a maximum frame rate or a server caps its data transmission speed to prevent a system crash, the fabric of spacetime restricts how fast objects can update their coordinates in the matrix. The speed of light isn't a law of nature. It is the maximum clock speed of the cosmic CPU. When an object approaches this limit, time dilates and warps around it, not because of abstract geometry, but because the processing core is working at 100% capacity to calculate that object's position. The pixelation of existence. If you zoom in on a digital image, you eventually reach its smallest unit, the pixel. Beyond this point, the image cannot get any clearer. It has a resolution limit. For centuries, physicists believed the universe was infinitely smooth and continuous. But quantum mechanics suggests otherwise. If you zoom in on the fabric of reality, on time and space, you eventually encounter the Planck Scale. The Planck length and Planck time are the fundamental resolution limits of the cosmos. Space-time is not a continuous fabric, it is granular. Reality itself is pixelated. Just as a game engine cannot display an object smaller than a single pixel, the operating system of our reality cannot render any event, measurement, or distance smaller than the Planck limits. If our universe is a quantum simulation, these constants represent the pixel grid and the clock tick of the host computer. We are not living in a smooth void. We are walking on a digital lattice, and the universe is built on discrete, calculated bytes of reality, staring into the mainframe. The realization that reality might be a specialized cosmic program doesn't subtract from the meaning of our existence. Instead, it adds a profound philosophical layer to our journey. If we are running on a machine, who built the machine? If we are in a simulation, what is happening in the real world outside? These are questions that force us to question everything. The anomalies we observe, from the unobserved double-slit experiment to the resolution limits of the Planck scale, are simply moments where the background code of the mainframe reveals itself to us. Perhaps we are not temporary biological accidents in a chaotic void. Perhaps we are unique data scripts living through a beautifully complex program designed to understand itself. The simulation isn't a cage, it is a canvas where code became consciousness. And right now you are looking directly into the mainframe and the code is looking back. Stay curious, stay AU Minds.